sense. Okay. All right. So condensed in just a couple of slides is what is some important things about our important sun, okay, or our important star, the sun. So I didn't bring it in, but I meant to. My beta fish really likes, I have a lava lamp next to my beta fish, and actually that is my cue for one of the layers of the sun. So we can think of the inside of the sun as being 3 layers. The core is actually where the nuclear fusion is happening. And I think on the board on Wednesday, or on Monday, on the board I put H plus H equal that, that's hydrogen. And I put a reaction arrow goes to form He, told me that's helium. That's what's happening in the core of our star, the sun. So there are actually 2 other zones, or 2 other regions. So we have the cores in the middle, okay? And then after the core, we have the convection zone. It's shown here, and it's also shown here. Convection happens a lot, not just in the sun. All convection is, and my lava lamp is convection, is you have basically a blob of warm. In the case of a lava lamp, you have a heating source down here, like the light is hot, and it heats the liquid, part of the liquid, and the liquid gets warm and it expands, and as it expands, it becomes less dense, and so it wants to rise. That's convection, that's it, okay? And actually we have convection in meteorology we can talk about, and convection in the interior of the earth we can talk about, but that's it. So in the sun, it takes the heat from the core, where the nuclear energy is, and it takes blobs of sun material plasma up, and that's convection. And then it gets the radiative zone, and radiative zone is the squiggle. A radiative zone is just the bump to bump to bump to bump. The radiation, actually, a good example of radiation is if you have an aluminum pan on the stove, your heating element is here, heating the bowl of your pan, okay, and of course the handle is out here. Convection is why your handle gets hot, okay? Not convection, I'm sorry. Radiation is why your handle gets hot. It goes from molecule to molecule to molecule in your pan up to your handle. That's radiation. So the outer layers of the sun look like this, and actually this is kind of why I brought in this figure. The outer layers closest to the radiation zone would be the photosphere. And the photosphere, I'm calling it an outer layer of the sun, but actually if we glance at the sun, we're glancing at the photosphere. After the photosphere, we have these gases, the chromosphere and the corona. Okay, so those are what we call kind of the sun's atmosphere. Here's a cool thing, solar wind. Oh my gosh. So where is the edge of our sun's influence? Where's the edge of our solar system? And as it turns out, actually, the sun is literally blowing charged particles in all directions. So there's a place, and it's way beyond Pluto. There's a place in our solar system way beyond the Kuiper belt we're going to talk about here in a minute again, way beyond the Oort cloud, where our solar system ends, and that's where the solar wind ends. Okay. So this is a close-up of the sun, and if I were to animate this, actually it reminds me of a beehive kind of, where these kind of small sort of honeycomb-looking features, those are granules, and the big blob is a sunspot. Now, I mentioned the other day that I've taught this astronomy at times where there are no sunspots on the sun. The sun is blank. Sunspots, that kind of blemish-looking thing that actually Galileo saw too, those sunspots kind of come and go. Granules are always there. So the word is granules. Granules are always there. Sunspots kind of come and go. The word is sunspots. So let me go ahead and this is lovely in this shape. So I have a lot of different words you need to fill in, but this right here, I don't know if you can see it very well, but along the x-axis down here, there are years, and along the y-axis are the number of sunspots. So you can see sometimes we don't have any sunspots, and then sometimes we have lots of sunspots, and then we don't have hardly any sunspots, and then we have lots of sunspots. Sunspots in and of themselves are kind of boring. Okay, we can see them with just my solar binoculars. But if you are in a period of high activity, you're going to have all of this other kind of crazy stuff going on. If you've ever heard the fact that the sun can be a hazard to the earth, this is what they're talking about, the rambunctious times of the sun. It takes about 11 years for it to go from peak to peak, about 11 years. So the solar cycle lasts about 11 years. There's some terms up here. This actually, you've heard of coronal mass ejection. Coronal means, we talked about corona as part of the sun's atmosphere. Mass means a lot, ejection means, okay? So a coronal mass ejection, abbreviated CME, that's one of the terrorizing things. It depends on where that spit from the sun comes, if the earth is in the path or not. You know, we can really, I wouldn't say the earth would be sterilized. And by sterilized, I mean like all life. But probably the most thing that would happen is, and this has happened before, are like electrical grids get screwed up. There was a really bad burp from the sun back in when they were doing telegraphs and such, and it like wiped out the telegraph communication. So this says that actually there's a we haven't talked about telescopes much. You guys saw some telescopes in lab yesterday, but some of the most powerful telescopes actually are beyond Earth. They are not on Earth. We have the Hubble Space Telescope that's orbiting the Earth. We have the Spitzer Space Telescope that was orbiting the Earth. We have all sorts of telescopes. We have some telescopes just dedicated to monitoring the sun. Okay. So we need to jot these down. These will be due when we meet again on Monday. Not supposed to have any weird weather events. So that whole deal about is the sun being rambunctious, kind of part of the 11-year cycle, or is it being nice and quiet? That's what we call solar weather. And one of the things with regard to solar weather is if you have assets, like the Hubble Space Telescope and the sun's going to burp, you want to try to close up the Hubble Space Telescope if you can protect its innards. The other assets would be human assets. You want to make sure you minimize them to dangers that the sun might be spitting out at you. All right, so on to something a little different. Again with our solar system. This goes back a few weeks ago when you guys did your awesome solar system models. You got a sense for this. We're going to kind of build on that. We kind of have two types of planets. We have the inner rocky planets, the first four, and then we have the outer four. Yes, ma'am.
Can you go back?
This one? Okay, yep. You're fine. So I could on this, and they're actually all shown here. So if the sun is over here, then we have the four rocky ones. Okay, these are the four rocky ones, and these are the four gas giants. Do you think they're really that close together? No, we kind of talked about distances and all that. So you kind of need to talk about what they might have in common. Now, one of the things about these gas giants, and I think I mentioned this, is that they all have bands. Of course, Jupiter has the coolest bands. They all have rings. Saturn has the coolest rings, but all those gas giants have that. And it's like they swallowed a terrestrial planet, so that if you were to fall, they're gas giants, right? So if we land on the surface of Jupiter, there's nothing to settle on. So we're going to fall, and then you'll get to the middle of Jupiter, and there'll be like there's a rocky planet, a terrestrial planet. I know it's not a really terrestrial planet, but I think that's funny. I think we mentioned an AU before. If we didn't, here it is. AU, capital A, capital U, stands for astronomical unit. Okay, and that is the average distance, since we're all that. The Earth is all that. It's the average distance between the Earth and the Sun. Of course, we know that varies because we know, according to one of Kepler's laws, the planets orbit the Sun in ellipses, not circles. And the Sun is not in the middle, it's kind of offset at what we call one foci. But this is actually showing you in AUs how close the planets are. Sol, what's Sol, do you think? The Sun. It is the Sun, and it's a distance from the Sun. Then we have Mercury, about a half an AU, Venus, 0.7, Earth, 1. Okay. Ceres, actually, and I think it made it to the review sheet I gave you for your exam, and we'll be talking more about Ceres. But what is between Ceres and Jupiter? Sorry, yeah, Ceres, Mars. What is between Mars and Jupiter? The asteroid belt, exactly. And actually, Ceres is one of the asteroids. It's the biggest asteroid in the asteroid belt. It's fancy. So here are gas giants. Okay, so Jupiter, a little more than 5 times the distance that Earth is to the Sun. Jupiter's to the Sun. We go out here to Neptune, about 30 times the distance from the Sun than the Earth is to the Sun. These are, I think, kind of, what does rotational period mean, you think? What do you think a rotational period means? How long it takes the planet to rotate? Yep, how long it takes to spin on its axis once, exactly. What's the fastest spinning? What is the fastest spinning planet? Okay, I can't do Sirius. If you take Sirius out, what's the fastest spinning planet? Jupiter? Yeah, Jupiter. It's about, I think, 9-10 hours to complete one spin on its axis rotation. Cool. Well, what's the orbital period mean? What's that mean? Rotation, spin, what's orbital period? How long it takes to go around the Sun? Yeah, how long it takes to go around the Sun one time. So which planet takes the longest time to go around the Sun?
Pluto.
Yeah, Pluto. We throw Pluto in there. Or Neptune, yeah. That's a long time. That's how many years. That's how many years, not days. That's years. Dang. Okay, the density of water is density of snow. I can't do that. But, so, which one has the most moons? Jupiter. And I think 63 is on the low side. I think it's even more than 63 now. You need to look it up. Do all the gas giants have moons? Yeah. What other terrestrial planet other than Earth has a moon? Mars. It is Mars. Yep. Mars has 2 moons. They look like potatoes. Yep. The busiest place in our solar system is, and I can't see this very good, I'm going to dim the lights. The busiest place in our solar system is gotta be Mars. So, barely see it. This actually doesn't do it justice. It's trying to kind of show you all the different places, all the different spacecraft and studies that we've had in our solar system. What's ESA? What is ESA? Yeah, it's that. It's the European Space Agency. So not only NASA, but ESA has been very busy. All right, we're going to kind of hop, jump, and skip through. I think I'm going to dim the lights again so you can see these. I have just a few images of the planets. Does this look like the moon to you? This actually is Mercury. We're going to go in order from the sun outward. So this is Mercury. Very little atmosphere. And that's actually related to, I think, 2 things. One thing is its mass is so light. And the other thing is that I think it's pretty darn close to the sun. It's got all that solar wind blowing it. One thing about Mercury is, if I'm Mercury now, of course, this is my daytime, okay, this is my nighttime, and it rotates so slowly on its axis. I don't know if I don't have mine with me, but it's like, can you guys tell how long it takes to complete one rotation? It takes 59 days to spin on its axis one time. That's a lot. So anyway, the daytime side is very hot, the nighttime side is very cold. Mercury and Venus are what we call kind of inner planets relative to the Earth. I tried to kind of convince you of this, but if you picture, I'm the Earth now, so I have Mercury and Venus, and now this is my nighttime, this is like midnight. I can never see Mercury and Venus at midnight. I'm only going to see Mercury and Venus as they are kind of close to the sun. Sometimes they're actually kind of called the morning stars. I've looked at Mercury through a telescope. It just kind of looks like an orange little circle, okay? And then I have on here that actually I think this is the Caloris Basin. If I'm looking for something to pull from Mercury, this is kind of things I pull from Mercury. Another thing is that it's got this crazy impact crater. That it's so crazy, Caloris Basin is so humongous that actually on the backside of Mercury, when it occurred, it got like little ripples in it, like the concussion, the impact went through the planet. So it's kind of cool. Now this is our little reminder that anytime you see anything that doesn't generate its own light, like a planet or a moon, the only way you see it is because the sun is striking it and that light is coming back to us. But just to kind of remind you when we look at planets, the planet's not glowing. It's only reflecting light from the sun. Okay? Here's Venus. Not a real good picture. Venus actually looks more like fuzzy, like this kind of purpley looking one. I've never seen it that color necessarily, kind of whitish. But you won't be able to see the kind of nice crisp surface features like that. We know what the surface features of Venus are because we've actually put, well I didn't, but somebody else did, put a spacecraft in orbit about the planet Venus and used radar to kind of get the topography of Venus. Venus will go through phases though. To me, what sort of phase do you think this looks like? How many people think it looks, well your options are crescent or gibbous. How many people think it looks a little more like a crescent? Me too. So would it be how many people waxing or waning? How many people think this is a waxing crescent? How many people think this is a waning crescent? Me too. Why is it waning?
Because it's going away.
Yeah, because it's going away. So one of the things we want to know about the planets is, are they still geologically active? Are they ooey-gooey in the center so that they can, like the Earth has volcanoes and what we call plate tectonics? Not quite sure. It's got old throw volcano on it. Venus actually is kind of, I know, like there's the sun, there's Mercury, very hot daytime, and very cold nighttime side of Mercury. For Venus, it's just hot day or night. And the reason for that is actually one of the things that the Earth is worried about right now. This idea of having an atmosphere that acts as a blanket. Specifically, things in our atmosphere, such as carbon dioxide. Venus's atmosphere is chock full of carbon dioxide. It can act as basically, it doesn't let heat go, which if you're cold, that's a good thing. If you're already kind of warm, it can actually warm up a planet. So Venus sometimes is talked about as having kind of the runaway greenhouse effect. Venus has got crazy daytime and nighttime warm temperatures, and that's due to its thick carbon dioxide atmosphere. Venus, you guys told me, is one of the ones that spins backwards. So all the planets orbit the sun on the plane of the ecliptic, okay, the plane of the ecliptic, the record kind of thing, and they all orbit counterclockwise. But Venus and Uranus actually spin clockwise. Uranus is flying on its side, so that doesn't really count as much as if we were to look at the planet Venus, instead of spinning, Instead of spinning counterclockwise, it spins clockwise. So it spins counter to the way it orbits. And we think that that was just because it was hit. It was hit even more than Uranus. It was hit extra hard. It basically did a 180. Okay, that's rotation. All right. So Mars. Here we go. Mars is a busy place. So this looks like it could be somewhere on Earth. This little tiny little picture. That is actually the surface of Mars. Oh my gosh, there's so many cool pictures out there of Mars. How many people saw the movie The Martian? I did. I only saw it once, but so I'm not a hardcore. But it's good stuff. The reason it has this red sort of appearance actually has to do with rust, iron oxide. It gets that rusty appearance. This is a look at the disk of Mars, and you can kind of see that. What does that look like there? That thing at the bottom there. It looks like an icy hole. Yeah, it looks like an ice cap. And it is an ice cap, but it's not like ice, like H2O ice. It's CO2 ice, carbon dioxide ice. Yep. A few features about Mars. This doesn't necessarily do it justice because you can't see the whole planet, but this is kind of a close-up. I don't know about you, but this looks like the Grand Canyon to me. So Mars has kind of a rift near its equator, but its Grand Canyon would go actually from our coast to coast. Okay, and it's called Valles Marineris. Another feature on Mars is it's got this. Does that look like kind of a volcano thing looking to you? That's to me. Actually, here on Earth, we use the term caldera too, and it's associated with volcanoes. A caldera is just kind of the big bumpy part, like this, kind of like a shield volcano to me. So it's called Olympus Mons. What else about Mars? Well, Mars' axis of rotation is tilted similar to Earth's. But as far as sister planets go, it wouldn't be Mars. I've heard it put that Venus is more like Earth than Mars is like Earth. I don't know. Size-wise, Venus is closer to Earth. Mars is a little smaller than Earth. But it does have that tilted axis of rotation, so it does have then seasons. And this cap right up here, okay, this polar cap down here, I don't know if you guys can kind of see these kind of dark areas. I'm pretty sure that when this photo was taken, those are dust clouds. Okay. So one of the things about Mars is that as Mars orbits the sun, it goes through seasons, and we're going to see those poles kind of shrink and expand, and also we're going to see our dust storms kind of come and go.
Why a lot colder than Earth?
I think it is. Yeah, Mars is colder than Earth. Yeah. And you remember what made Venus so darn hot, makes it so Venus so darn hot is its carbon dioxide thick atmosphere. Actually, Mars has a carbon dioxide atmosphere too. It's not as thick. Yeah, it is colder. With regard to water, so there's frozen water on Mars, and if you kind of chase it down on the internet, Mars is a very busy place, so actually it's been caught in action, kind of some flowing water, liquid water in a sense. It's kind of like it was here and then it was there, I don't know. So there is some evidence of liquid water. But there's definitely evidence in the landscape that there was not just sneaky liquid water, but Mars used to have a lot of liquid water on its surface. You can kind of see like riverbeds in the surface of Mars, and you can also see kind of like, if you know what sand is basically over time water has eroded rocks and pebbles and made that kind of little piece of sand. Mars has sand like that too. Yep, Mars has 2 moons. Earth only has 1 moon, but Mars has 2 moons, but here they are. They're nothing like our moon. Meet Phobos and Deimos, meaning panic and fear. So, and they think that, how our moon was made, our moon is actually a piece of the Earth, okay? They think instead of that, actually, Phobos and Deimos were just kind of captured moons, captured satellites. They got too close and have been there ever since. And I mentioned about the ice caps and the dust clouds. Oh, this says sometimes you can see it through telescopes. That would be the only feature you can see through a telescope for Mars. All right. So between Mars, the last terrestrial, and Jupiter, the first gas giant, or Jovian, you guys told me is the asteroid belt. So the thing about the asteroid belt is sometimes and I do it myself, I'm like, oh man, I would not want to have to drive through the asteroid belt because I'm afraid I'm going to hit something. And that's a misconception. Like you can see, most of the little rocks that you run into in the asteroid belt are way far apart. Some asteroids have their own satellite, have their own moon. How cool is that? Asteroids, instead of trying to use space technology to kill people, I think that we should use space technology to do something like this. Land on an asteroid and see what sort of minerals and things like that we can bring back to Earth. And so they're actually looking at that. My husband kind of into space and stuff, science, he's definitely into science. But he said he was reading that NASA has on the books in the next, I would say, year or so, to basically take an asteroid and to visit the asteroid and to change the asteroid's trajectory. Now this is for obvious reasons. We're going to see that there are different types of asteroids. Asteroid is just a chunk of rock that's in space. Of course, a fear would be that one of those asteroids gets a wild thought and basically makes an interception course with Earth. Okay, so that technology to be able to manipulate or to bump them is important. But not, the asteroids aren't necessarily an issue with regard to Earth, but they can be. If the asteroids were all like gathered up in asteroids in the asteroid belt, they wouldn't be as big as the moon. So it's not like there was a failed planet there. I mentioned Sirius, or actually we had Sirius on that slide of different different planets in our solar system. Sirius is not a planet. Sirius is a planet as a dwarf planet. Okay, Sirius is a dwarf planet. What else is a dwarf planet? Starts with a P. Pluto. Pluto's a dwarf planet. Sirius is a dwarf planet. And we've got some great pictures of Sirius. This is Sirius, and actually kind of cool little white little reflective part there. Awesome. I've not done it before, but sometimes you should be able to spot asteroids. Now, through telescope. Now, do asteroids glow? How do we see asteroids?
Water and stuff coming off of it?
That could be they're reflected because of water, but my point was going to be they don't glow. It's the sunlight that hits them. Yep. Yep. Jupiter. Okay, so Jupiter is our first gas giant, and Jupiter has got the coolest belts. Okay, like the belts. You can kind of see the banding, kind of like the stripes. Actually, they're called belts and zones, and they alternate going to, like they're gases. Gas going this way, a band of gas going this way. This way. Isn't that cool? So when we study stars, we're going to see that a lot of stars have a buddy. A lot of stars were born with a twin, like a companion star. So, but you can see that Jupiter had a ways to go if it was going to be a companion star to our sun. They could have. These are 4 moons that Galileo saw orbiting Jupiter. They're called the Galilean moons. They have their own little personality. As it turns out, if we actually are going to these gas giants, Jupiter, Saturn, Uranus, and Neptune, and if we want to land a spacecraft on anything, it's going to have to be their moon, because you can't land a spacecraft on a gas giant. We have actually sent, I think it was Galileo, the spacecraft Galileo, actually purposefully fell into the planet Jupiter, and it sent back some information as it fell. Galileo, that spacecraft, that man-made spacecraft, he didn't want it to, I think it was running out of energy, and he didn't want it to be random. So you're like, dude, kamikaze. Okay, so Jovian planets, Jovian planets, are you guys okay that Jovian means gas giants? Jovian gas giants means interchangeable. No solid surface, but they have a cute little core, a little rocky thing in the middle. So the clouds are made of kind of an assortment of things, including ammonia, hydrogen phosphide, and water. So the great red spot would be like up here. And I'm thinking this image was taken when there was a, okay, you see this guy? But you see this one? I think that was Red Spot Jr., who didn't last as long as the Great Red Spot. Great Red Spot's still there. Actually, I remember some of my astronomy friends talking about this. The Great Red Spot is getting smaller and smaller. Okay, so yeah, Galileo saw these four moons orbiting Jupiter. And actually, if you kind of remember the setting for Galileo was when they were kind of coming out of the fact that we actually all orbit the sun instead of we all orbit the Earth. So the fact that he found a planet out here that had its own moons was then like kind of consistent with the idea that we orbit the sun. Okay, Saturn. Saturn has the coolest rings, but they all have rings, right? Saturn actually has banding like Jupiter, but not as cool as Jupiter. Saturn has lots of moons. One of Saturn's moons is the moon Titan. And Titan we have actually landed on. Titan is of interest because it has an atmosphere, it's very large, and instead of having a water cycle, it actually rains liquid methane. Another moon around Saturn is Enceladus. And Enceladus is amazing in that we've seen it like squirt out water. Okay, so that is Titan. There's Titan. So there we landed on it. Spacecraft called Huygens. And this is Enceladus, spitting out its water. Is that not cool or what? So there's liquid water down here, and actually there's been science fiction movies written about, well, let's just get a spacecraft years from now, and we're going to land on this moon of Saturn. And if you have liquid water, like we know there is on Enceladus, then if you have liquid water, you have the chance for life. So of course, we're seeing this there. Pretty cool. So the cool rings we see around Saturn haven't always been there and won't always be there. But they're basically, I think I've heard it described, kind of some moons kind of crashed into each other and made this kind of skirt or disc of material. Now it's the rings around Saturn are not a solid thing, they're kind of like little crumbles, okay, relatively close together, and they're very reflective. All right. So Saturn's rings, oh, by the way, this also says, can you kind of see some, like there's a nice little ring, they have gaps and they have names for the rings and everything. The rings are tilted so that sometimes through a telescope, like if that's the Earth and now I'm Saturn and and my hand's supposed to be kind of the rings around Saturn, they're tilted relative to the plane of the ecliptic. So sometimes we see them kind of face on, or if, I guess we'll turn that into, not the sun, we'll turn that into Earth. But we see them kind of doing different tilts. Sometimes they're face on, sometimes they're more like heading. All right, so this is, after Saturn, we have Uranus. So Uranus should always be kind of its axis of rotation, which is going this way, should be kind of tilted. It lies in the plane of the ecliptic as it orbits the sun. So this is the first of two blue planets, and they're blue both for the same reason, due to methane, the chemical methane. So here's Uranus, and here's a cooler look. You can actually kind of see some of the wispy sort of rings around Uranus, and you actually see a couple of the moons around Uranus. I can see kind of the banding feature. And the reason its axis of rotation lies in the plane of ecliptics because it got hit. Not as hard as Venus, because Venus did a whole 180. Yeah, I've seen Uranus through the telescope, and it's pretty. It's a little small little disk. Neptune then, right? So this is kind of a look at the solar system where, I don't know if you can make it out very well, but here we have Jupiter, Saturn, Uranus, and Neptune, and then of course we have Pluto. So one thing about Pluto is Pluto's orbit is kind of outside a little bit more the plane of the ecliptic. Neptune's blue because of methane. Here's kind of the surface of Neptune, the gases in Neptune. There are clouds that are kind of making that cool sort of faint pattern. This actually is called the Great Dark Spot that was there in the 70s, I believe, kind of like the Great Red Spot of Jupiter, but the Great Dark Spot of Neptune didn't stick around. Neptune actually has the fastest moving winds. This is a close-up of one of the moons that orbits Neptune, and darn it, I'm gonna fix this. And its name is not Titan. Its name is Triton. Ooh, thought it was gonna die for. Oh, it did die for you guys. Hang on. That's better. I didn't know it would do that. That's crazy. Yeah. I don't like things that sound similar, so they sound similar. But I fixed this slide. I don't know if you need to fix it too. Triton, Triton, actually is this guy right here. Kind of has a couple of weird sort of, they kind of call it a cantaloupe. I don't know if it looks like cantaloupe to you, but they say it kind of surface kind of looks like a cantaloupe. It's described as Triton orbits Neptune. The fact that it's kind of doing a backward sort of orbit means it's getting closer and closer to its planet. What's the deal with our moon? Is it getting closer to the Earth or farther from the Earth? Yeah. That has to do with kind of how it's orbiting, our moon's orbiting Earth. This guy's going backwards, so it's going to run into its planet and probably make another ring. Okay. So, Pluto, no longer a planet, but a dwarf planet. This actually is the person who discovered Pluto, Clyde Tombaugh. And the way he discovered Pluto is he saw it wandering against the background stars, not just like willy-nilly, but actually kind of on a path, and said, hey dude, that is another planet. And he's right, well, now dwarf planet. But for his efforts and such, his ashes, he's deceased, his ashes were actually placed aboard New Horizons, a spacecraft that left the Earth and went past, drive-by past Pluto. We got some amazing photos from New Horizons, and his ashes are aboard that. And then actually New Horizons, the spacecraft, I think I might have told you, on New Year's Eve night, flew by another sort of crazy little object out there. Well, actually it's just in the Kuiper Belt object. Looks like a little snowman. But anyway, so it was demoted, Pluto was demoted. I think I explained this before, that in 2006, finally they defined what a planet is. Before they just kind of didn't really have a definition of a planet. So the criteria that Pluto failed was it did not clear its orbit. Fourth thing. Pluto's a dwarf planet, Sirius is a dwarf planet, and there are actually other dwarf planets out there in the Kuiper Belt. Pluto actually has at least 5 moons, and they're here. So here's Pluto, and here's its 5 moons. Actually, its closest moon, Charon, is a similar size to Pluto. I mentioned that Pluto's been visited by that spacecraft that has his ashes aboard. How fitting. So these, I'll give you a minute, these will be due also. Okay. I got 3 minutes. I would love to finish this up. All right. I kind of feel like we've been talking about these two things. Kuiper belts. Here, kind of Pluto's in the Kuiper belt. We call them, stuff in the Kuiper belt we call Kuiper belt objects or KBOs. How clever is that? Oort cloud, kind of, you see this itchy looking thing? This is the Oort cloud. So think of it as a spherical kind of distribution of stuff around our solar system. Sun's in the middle, roll planets in the middle, Oort cloud, Kuiper belt. So those icy things, actually, if you have an object in outer space that has rock and ice, you call it a comet. That's it. Okay? So those things have been out there kind of since our solar system formed. And our solar system formed about 4.6 billion years ago. The sun turned on about 4.6 billion years ago. Now, comets you've probably heard of. Well, sometimes we see comets in the nighttime sky. And I don't think we're going to have time for this. I'm getting distracted. Because we need to talk about comets and meteor showers. How are you going to start? How close am I? Yeah. We're gonna. I'm not gonna. I can't do all that. So we're gonna pick up here with comments on Monday, and then we'll just kind of go from there. Thank you. Have a good weekend, everybody.